Hello, and welcome to Day 5 of Advent of Elixir. Today's topic is going to be a little bit of a deep dive into one of the, I think, more useful parts of the Beam virtual machine that sometimes doesn't really get a lot of love. So what I'm going to talk about is ETS. And what ETS is an in-virtual machine, so in operating system process, tuple storage engine. It's basically just a place where you can stash a bunch of tuples. The most common sort of tuples that you are going to stash inside of ETS, but by no means the only type you can use, are two tuples, which would effectively make it an in virtual machine KV store, much like Redis. And you can put on some convenient restrictions, like, for example, making the first part of the tuple pair required to be unique. And what's great about ETS is that, one, it exists inside of your virtual machine, so that means that access is very fast, updates are very fast, and it gives you all of the concurrency locks that you need so that you don't have two processes trying to access and or update the same data and have them stomp on each other. So I'm not going to go too much into detail what all of the functions in the ETS module do. I recommend looking that up in the Erlang documentation, and I'll put a link below. But what I do want to do is go over how to use matchspecs. And so this is the query language that you use to access information inside of your ETS table. The documentation is not entirely clear. It's a little bit hard to understand. And so I recommend having maybe like a little bit of a cheat sheet to understand how to do that. And that's what this is going to be. So if you're kind of new to Elixir and Erlang, this is probably not at the right level for you. But if you're intermediate or advanced, this is definitely something that having it in your back pocket can be very useful. There are parts of the Elixir standard library that use ETS under the hood. For example, the registry module. And, if you want to understand exactly what the registry module is doing when it is registering processes, understanding how ETS works is important. And in fact, there is something called registry.select, which uses ETS match specs. And for me, needing to understand how registry.select works was my first intro into ETS tables. So let's get started. I'm going to spin up a virtual machine, and we're going to run advent.maketable, which will give us an ETS table. And you can see on the left here exactly what it's doing. Great. So one important thing to note is that the resource that corresponds to your table is actually a reference. This is not one of the types that you see too often, but one of the things that a reference will do is it will represent a resource that has been made that exists as some sort of opaque resource, especially if that uses some C code under the hood, which if you think about what ETS is doing in order to get very high performance, that's what it is doing. I'm going to assign this to the table variable. The way I'm going to do that is called a V. If you don't know what V does, it's like the ANS key on Elixir, so that's a little bit of a bonus for you. You can also do, by the way, this, which will call back to a previous IEX number and give you the value there. So since we've made this table, let's do the most basic query. And this will give you an idea of what the structure of these functions, of these match specs are. So the way that you search for content inside of your table canonically is to use ets.select. So let's go ahead and do that. We're going to select on the table. And this is the first query that I'm going to show you. Now, it looks a little ugly, but I think it will be useful to show what's going on. Okay, so note that the match spec which is this like term in the back here, is a list of 3 tuples. And so we'll get into what the list does later. But the important thing to note is that the first part of the 3 tuple, which I'm highlighting here right now, is matching on the structure of the tuple. The second part is what we call a filter, or a list of filters. And the third part is the output description. Okay, so let's look at this first part. What I'm saying is with this atom, that is the atom string $1, it says create a variable, and I'm going to assign that variable to the number 1, the first variable, and match that entire variable against the tuple. And then the output should be a list of all of those variables that have been matched. So let's go over here and take a look at what it's done. Note that these have been inserted in this order and they come out in the reverse order. Baz0 is the first, is what gets matched first, right? And that gets output directly. Bar2 gets matched again, and then output directly. Foo1 gets matched, and then output directly. So this is what we get. The tuple Baz0, Bar2, and Foo1. Okay, but suppose I want to actually use this first part, which is the matching part, on our content. So let's go ahead and do that. And what I'm going to do is I'm going to change the match spec a little bit, and we're going to use this one. So let's look at this. This says match on a 2 tuple. Assign the first part of the 2 tuple to the variable 1, and then discard the second part of the 2 tuple. No filters, and then output the first match. So what this is going to be is this is going to basically be a list of keys in the key value table. Bar as foo, exactly what we expected. How about guessing? I'll give you a moment. How about guessing what it would look like for something to match just the values in the key value table? Okay. So I'm going to do this. And that is a select statement that will match on the values. Now, note that I use $2 here, but actually, it doesn't have to be $2. It could also be $1, and that would work just as well. But I wanted to show you that also you can use other numbers instead of just 1 and 2. They don't have to be sequential. All right. How about recreating the first one, except instead of doing a key value pair, like in line 4, what we're going to do is we're going to swap the keys and the values. How do we do that? It'll look like this. And this is going to be kind of the first foot gun with ETS tables. So here we're going to match both the key and the value. We're not going to filter anything. And then we're going to output a tuple that is we're not going to filter anything, and then we're going to output a tuple that is the value followed by the key. Note here that the tuple is nested inside of another tuple as a singleton. And for some reason, which I don't fully understand, ETS needs to have a tuple as your output wrapped inside of another tuple. So let's go ahead and run that, and you can see we get 0 baz, 2 bar, 1 foo, which is what we expected. What would happen if we didn't put those in? We would get a match spec complaint that it's not a match spec. I also want to note that it's not absolutely necessary for you to output a tuple, right? So one thing you could do is you could output as a list. And here you can see you get the list of 0 baz, 2 bar, and 1 foo. You could also even match it as a map. So I'm going to call this one value, and I'm going to call this one key, and then, oops. So now the structure of what we're outputting is going to select as a map of value and key. And I messed something up. There we go. And so here you can see that it declares that the key is baz and the value is 0. Key is bar and the value is 2. Key is foo and the value is 1. So now let's talk about filters. So filtering itself uses a fairly complicated language where that somewhat looks like an abstract syntax tree. And I'll give you a really basic example. So here what we're going to do is we're going to take the keys, or excuse me, the values, and match them to be when they're greater than 0, and then output the values. So this should give us a list of values that are greater than 0. That should be, if you look to our left here, exactly 2 and 1. Okay, so as you can see, the way you declare that is with a 3-tuple, and this particular 3-tuple is the greater than operator, where you match the first variable, which is $1, and then you compare it against the value 0. Now, I would caution you to be careful. Sometimes you may think that you have the correct one, and it will say that it's an invalid match spec. That's because some terms that when you're comparing to need to have this be in a tuple called const, and this will give you the correct type of match spec. Of course, 0 is a number, and for whatever reason, numbers don't need to be wrapped in const. But for example, if you are comparing equality to a string, then you will need to put the string in const. Okay, so I'm going to show you another one. We're going to in this case match against values that are greater than 0, and then output the key. So note that this is important because your values don't necessarily have to appear on one side or the other. So let's take a look at this. We're going to read it, and it says match the tuple as variables 1 and 2. Check to see if variable 2 is greater than 0, and then output the variable 1, which would be the first part of those tuples. And here we get bar and foo, and if we take a look, we see that bar and foo both have values that are greater than 0, so that's exactly what we expect. Okay, so let's do one more. And what happens when we put more than one filtering tuple in here? Well, as I suggested by using the term filter, each of these will be applied as a filter that removes things that don't match the criteria. So one way to think of this is that this as a series of filters is that it must the terms and the variables bound in the initial match must match and satisfy an AND relationship between all of the things that are inside of this list. So let's take a look at an example. And we're going to use a somewhat long example here. So let's read through this. So this says take your tuple and match $1 to the first value, $2 to the second value. Then we're going to check to see that $2 is greater than 0, and check to see that $2 is less than 2. and then print out the key, which is $1. So looking through this, we expect the result to be only foo, because bar is greater, bar is less than 2, is not less than 2, and baz is not less than 0. So we get only one answer back, and that's foo. Conversely, note that the entirety of this match spec, these match spec triples that we've been talking about so far, have been wrapped inside of a list themselves. What happens if I take 2 triplets and put them next to each other into a list? Now, think of this as the opposite of before, where the inside match has to be an AND relationship. The outside match is not, instead of a set of filters, think of it as a set of options. And what do I mean by options? What I mean is that if it fails to match the first, anything in the first match spec, if any given tuple inside of your ETS table fails to match the first match spec, then it will be checked against the second one, and if it matches the second one, then we'll put the result in. So let me show you what that looks like. So let's read this one. So we're going to match the tuple as $1, $2. We're going to check to see if $2 is less than 1. And if $2 is less than 1, then we're going to output the key. Then we're going to, if that fails, then what we will do is we will match $1 with $2 again, check to see if $2 is greater than 1. And if that is the case, then we're going to put the value instead of the key. So what we expect our list to be is, let's go through this one by one. So the first one is baz 0. Baz 0 is less than 1. So we are going to output, baz. Then we're going to hit bar. It's bar 2. Bar 2 is not less than 1. But it is greater than 1, and so we're going to output 2. And then for the last one, foo1 is not less than 1, so we don't output anything. And it's also not greater than 1, so we don't output anything either. So we expect to see baz, 2. And that's exactly what we got. Great. So these ETS tables select statements are somewhat challenging to read. What recourse does one have? Well, interestingly enough, if you think about it, these sort of match specs kind of look like functions in Elixir and Erlang. And to that end, there is a function called fun to ms. So let's do that. And for example, what I'm going to do is we're going to match against the second value, and then we're going to say when x is greater than 2, and then we're going to output x. So you see how I'm writing a lambda, and I pass it to this ets.fun2ms function, and what are we going to get? We're going to get an ets statement that looks exactly like how we expect. So here, the first part is don't match the second term. We're going to assign that to a variable 1, which is equivalent to x. We're going to select when x is greater than 2, and then return x. Now let's also take a look at this other one. So I'm going to modify this. And note that x, y, when x greater than less than 1, then we're going to do y. Note that multiple function heads kind of looks like the outside version. Maybe let's also do and y greater than 3. So note that the outside version, the outside set of filters is equivalent to the list. The list of the different function match head is equivalent to having lists of the outside triples, and it will also generate using this and also, which is equivalent to the and keyword. And it will check to see that it'll apply the two filters here when x is greater than 1 and y is greater, or when x is, less than 1 and y is greater than 3. So fun2ms is a nice and fun way of generating these match specs if you don't want to do it by hand. Okay, so hopefully this video has helped clarify how some of these sometimes very confusing terms work. I do want to show you one last foot gun that you might run into if you try to use fun2ms. So one might think about doing something like this. ms, stop fun2ms, and then let's do fnx when x is greater than 1, x. And then, let's make a function with this. So, def filter for select table match spec. Oops. So you can imagine trying to write something like this. Well, what happens when I try to do that? Unfortunately, we get a compilation error, and it says that fun2ms can't be called with just a normal function. It has to be called, see, it says function called with real fun should be transformed with parse transform or called with a fun generated in the shell. So really, we can only generate functions from the shell. And that goes for if you don't try to make this a attribute. So perhaps I might try to get around this by doing this, where I write out a variable. And what this will do is, unfortunately, it'll compile, and then when I try to do advent.select, we're going to now push this error into runtime instead of at compile time. So really, you can only use ets.fun2ms on the shell console, and unfortunately, that's a little bit unfortunate, but there is also an Elixir library that will allow you to generate fun2ms on the fly. Okay, so I will see you tomorrow.